Hi there, this is Matt Heffernan. Welcome back to my channel. This is another episode of Slithy Vlogs, my unscripted, lightly edited, sometimes barely edited at all, low production value videos that I am doing every other week. So what you may notice is that normally my vlog episodes for the past 9 episodes had come out every Thursday, and I had my proper edited, scripted type videos coming out every Monday, and I'm going to be shifting that production schedule. Just can't keep up with that. Sorry, I do have other things I have to deal with. So this is going to be starting to shift my schedule, and what we're going to have is videos only on Monday and alternating between these vlog episodes and then the scripted episodes. So a bit of an update, the last scripted episode, which was the first episode in my earlier announced series for Z80 assembly language, a tutorial is primarily focused on the ZX Spectrum. And that's done very well. I thank you for your support. I'd like to see all these new folks coming to the channel and subscribing for that, in addition to the whole tidal wave of folks that came and subscribed from just the announcement video from last month. So I hope this is matched and lived up to what you had anticipated, and that the future episodes are even better. So the next episode will be coming a week after this. So this will be not this coming Monday, because I'm going to try to get this out over the weekend. Hopefully this is coming out on Saturday for you to see. And then Monday, June 14th, that around that time is when you were going to see that the next episode of that comes out. But it will give me 2 weeks to do these larger episodes and then squeeze in some of these vlogs in between. And if you're enjoying my tutorial series, I would also recommend checking out Happy Coding ZX, run by my friend Alan Turvey. He is creating a similar series. He's on his third part that just came out a few days ago, which is based on the Usborne books. And for my British viewers, that's pretty familiar with you, but for American viewers, this is a series that was very popular in the UK for teaching assembly language and just computers in general from the very ground up. Sort of like the For Dummies book, but a little more serious and a lot more old school. So, and also he's creating his own game based on asteroids and really doing a great job recreating those vector graphics. So check out Happy Coding ZX and throw him a subscription. Done with that, so right now getting into what the subject of this week's vlog is, and that of course is another update on my game Pop. And as you can see here, I have some graphics now. I did not have anything within the emulator to show you last time. I just had like a spreadsheet and a little smattering of code to show for it. And now I have actual functioning code for doing a tile map engine for the game, and a little bit of animation, which we'll see right here is the Canon. Yes, we can move the Canon back and forth right now with Z and X, but I've got it set up so that eventually we'll have a menu in the game and you can set controls you want. But what I'm looking at doing by default is Z for moving the Canon left, X for moving it right, and then space bar for shooting the bubbles. And so what we're going to have here as we're moving the Canon around, going up into the field of play will be a sprite, quote unquote sprite. Basically, it will be a small circle showing, approximating the trajectory of where that bubble is going to shoot out based on the current angle. And so we'll have that, and then of course also the animation of the bubble actually shooting out of the Canon and then joining one of these little positions up here. And you can see I also have the hydraulic press, and I've got it shown the press at the maximum depth with also having the maximum number of rows. So what you're seeing right here is like a snapshot of a moment in time where you're about to have a game over. Basically, once the layer of bubbles, the bottom layer of bubbles comes into contact with the bottom row where we've got these little pins here, these little silver pins, that's going to pop all your bubbles, and then it's game over. And yeah, even if you introduce a bubble to a bubble layer that is right on top of those pins, that will also be a game over. And so what I have is sort of a two-stage mapping for these bubbles. I have just sort of a bubble arrangement, which if we go into the code here, we'll see. Here's the top level pop.asm. This is where everything starts, and I set up my memory map. I'm doing some double buffering, so we don't have any flickers. So up at hex E1000 is where I am rendering my tile map to, and then of course I also have the color attributes up there, and then at the beginning of every interrupt, I am just taking this buffer and writing it out to the actual screen memory so that the colors and the pixels all get updated as quick as possible. Of course, with everybody's favorite instruction, LDIR, right there. So LDIR is going to just move everything from the double buffer for the size of the double buffer into screen mem. Magic happens in that one instruction. It is a long instruction. It takes a long time to execute, but there we go. So that's how I'm dealing with that. But then for the bubbles, like I said, there's a sort of a double sort of mapping that happens. So before we get to that, so the first level of mapping is the tile layer. Like I said, I'm creating a tile engine, and here you see I have tiles, and I do include tiles.asm. These are the actual tile assets. So this is just hex data, and that I have just painstakingly entered in. And those relate to the tiles that I have defined in the spreadsheet. You've seen this spreadsheet before, and here we can see some of the tiles for the balls, tiles for the scoreboard, and you can see here I've mocked up where things are going to look, numbers for the scoreboard, and then you can see here in the dark red part is all the Canon and all these different angles that the Canon can exist and all the different tiles. So I need a lot of tiles just to handle that animation, but that's okay. I can dedicate those. All right, I'm up to 218 tiles, of course, using an 8-bit index. So I'll have up to 255. So the remaining tiles, I've got basically all the tiles I need, as you can see here, for that animation. I don't need a tile for any of the sprites because those are just going to be sort of pasted over on top of the graphics buffer. And then I can just have some just repeating patterns, some very basic patterns. And the nice thing is that what I could define is a basic tile pattern that will go on either side, and then rather than having used the same tiles for every level, what I can do is just redefine those tiles every time so that I'm not updating what the tile indices are on either of these sides, but just updating the tile assets that are dedicated specifically to the background. So I could have all sorts of things. I'll probably do some sort of like a Arabic tessellation type thing. Those like interlocking patterns I think look really cool. And I think that'll be a nice contrast to the more vanilla, just bunch of bubbles in a bunch of rows that are going to be in the middle. So a nice textural contrast between them. Not going to have the big pirate scenes that we saw in Canon Bubble in my last one. And I got to figure out something to do down here. I know I'm going to have a next display right here, so you'll see what the next color is. The current color will be in the Canon that you're about to shoot. I will have a means of being able to switch between those two so that you could pull the next into the current one, and then the current one will be on deck. And then yeah, so I'll have that corner sort of taken up with that next. And I don't know, maybe it'll just say pop slithy games or something over in this end. Not going to get too complicated here because, again, I am going for making this fit in the 48K. I'm not going to have a ton of assets, but right now I'm sitting at a very small amount of code. Of course, I don't have any of the game physics in there yet. That's going to take up a good chunk of code. So yeah, so there's the tiles, and then so that's all the tile data in order, and then I have a tile map. So I have a 32 by 24 block set aside, all initialized to 0. And if we, of course, look here at tile 0, it's all paper. So all 0 going in there. And, oh, all right, well, hey, why not? We'll keep the, the 2 sets of tabs. So we'll have that blocks, and you notice, of course, that's also the same format as the color attribute memory. So that makes it 1-to-1, so that each tile will have, it'll be the same color attributes for all the pixels in that tile, because they're going to match straight up with that. So what I'm going to do is, as the game is played, we're going to be updating all of the tiles, and in the main thread we are going to be rendering all of the tiles, and we're also going to call this fill rows. And fill rows is over here in bubbles. So what we have is a even more concentrated sort of tile arrangement for the bubbles. So here's where all the bubbles are defined. These correspond to the colors. So colors 1 through 6, and 0 is no bubble, or a black bubble, if you were, but black bubbles aren't there. And then, yeah, I could go ahead and change those. So like right now, of course, color 1 is blue. But say if I wanted to make this corner bubble also red, like the one next to it, I'll make that 2. And then I can make it also look like we're not about to die. So you notice here we have alternating rows of 8 and 7, 8 and 7. So I'll make this last row of 7 all 7 zeros. So 0, 1, 2, 3, 4, 5, 6, 7. So I'll save that. So now we'll have 2 bubbles, 2 red bubbles there, and up here, and then this row at the bottom should disappear, so it looks like we're not exactly about to die. And if we manage to pop this green guy right into here, we may be okay. But we're still we're gonna die anyway. There's no way out at where we're at. So let me go there. Okay, I rebuilt it, and then I can just reload the snapshot. This workflow is working pretty nice so far. And there we go. Now we've got the 2 red bubbles up there. We've cleared out the bottom row. And now I could make the press actually come down another half a notch. So right now it's down 2 notches, which is a full bubble height. And I could go in here and change my press depth, bring that up to 3. So the press depth will make that come down a little deeper. There we go. Oh, and obviously I've got a problem with this row. Oh, I can see what's happening. I am I am putting black bubbles over the top of that. So there, I've discovered a limitation. So I need to ignore those black bubbles when I do the fill rows, that I am not overwriting using black. If there's black bubbles, that I'm not overriding any of this. So let me then change. So you can see there, the press is down lower. Let me bring the press all the way up, because that's generally how, unless it's a really evil level, those are going to all start with the press depth at 0, and you'll have a lot more room to work with. So there you can just see the bottom plate of the press. And now, hey, we're not about to die. I've got a green one. I could pop that green one up against this guy, and then if I get another green one, I can start chipping away. This would, of course, be a very hard place to start for a level. So generally, like, the first levels are probably only going to be about 4 rows deep. And so then you're going to have another 4 rows to work with, and then again until the press starts coming down. But in those early levels, the press may never come down unless you're really taking a super long time. And so that would be sort of a merciful ending, is that, all right, that press is going to finally come. In that first level, if you can't beat that first level before the press starts coming down, then you're in some trouble. But So there we go. That's some of the basics. Also the score. I have the scoreboard as another sort of meta tile. That's the other one. If I go, do I have that on Canon? Where did I put that? No, I think I have that in the main. Yeah, so in the scoreboard here, I could set this. Let me give myself an extra, what is it? An extra 10 million points. So I'll add that in there and I'll build that up. So now I should go from 4,096 to 10,004,096 when I reload. So there we go. So that's how the scoreboard works. It's not BCD because you don't really have BCD support on the Z80. So I am just going to be doing sort of full byte decimal digits and dealing with the carries, so that when I add the score, I am generally going to be adding, if I'm just adding 1 to the score, say, or if it's like for a bonus thing, I'll be able to do the carries, but most of the changes to the score are going to be like hundreds or thousands. So the ripple effect is going to be pretty minor. So we can just do the math 1 digit at a time. There's not going to be any sort of BCD conversion. No need to keep the score in any sort of binary format. That should work just fine. And so what we're doing is we've got in the main loop, so we're doing that fill rows, which will take those bubbles, take these row indices, and map those into the tile map. So each of those rows, each of those elements within the bubble rows is going to be 4 tiles, like we can see here. And so they're going to have this 2x2 area that's the same color attributes, and then they're going to be these tiles, these 4 tiles. So real simple, a lot simpler than the scheme I had before, especially after I saw Canon Bubble, I want to call it Canon Bobble, that, it's okay that the rows don't overlap. Don't really need that. And so I think this ends up working out a lot easier. It's a lot less code, so things can be a lot quicker. I'm starting to get a feel for how fast the spectrum is, which is not very, especially with only a 3 megahertz Z80. It takes some time to do some stuff. So a lot of the things that I've been used to doing in a single scan cycle for, say, the Commander X16, I can accomplish a lot less with it. First of all, it's a 50 hertz scan cycle, which, I mean, you would think that, all right, fine, that's actually more time than a 60 hertz scan cycle, but we're dealing with a much slower processor. And yeah, I'm seeing now how chunky Z80 code can be in terms of like how long it takes to execute some basic things. So still working out that. So yeah, in the main threads where it's less time critical is getting these rows filled out and rendering all of the tiles for the whole tile map, and just continuing going through that main loop. Eventually I'll have a key for exiting. I'll have that defined, and then in like an exit state that will get us out of the main loop. But then in this Canon file here, we can see, first of all, I have these 8 tiles for the part of the Canon that changes as we move, which is basically these first 2 rows. So as you can see there, we get this sort of animation happening for these dark red parts. So I've got all the different frames for the animation, the whole range going from minus 45 degrees to 0 is going straight up, all the way up to 45 degrees, and all the way to the right. And that's it. So we have all of the different layouts for that. And then a tick handler, which you'll see here in my interrupt handler, I call First, the copy double buffer, which will take everything from that double buffer. It does the big LDIR to move everything from that buffer into the screen memory, and then it does the Canon tick. So this is what I'm going to do 50 times a second. And this is really the Canon is the player control, so it's going to have very specific things that we want to be responsive within that. So it's going to check the keyboard. So I went through the joys of reading the ZX Spectrum keyboard using the this setup here, where I've defined the keyboard rows, which correspond to Z80 ports. And so the Z and X are on the same row. The space bar is on a different row. Of course, these are logical rows, not physical rows. I mean, they're still physical rows, but it doesn't necessarily relate to the rows of keys that you see on the keyboard. It's more how that the key matrix is actually defined electrically on the keyboard. And then that all gets fed into these specific ports, these different key rows, these electrical key rows that each are sitting on their own port. And so I have the port number and then the bit within that to check to see if it's clear. So I'll do that. So I check first to see if it's going left. Then I'll check to see if it's going right. You could actually have them both pressed down. It will favor the left, is the way I have it right now. But if you're all the way to the left already and you're hitting the right button at the same time, it'll just go to the right and ignore the left. But it'll, it'll twiddle back and forth as you're doing that. So, in fact, let me test that here. Let me go over to left and there you go. See, there's the twiddle. So yeah, that's a little idiosyncrasy. But yeah, I've got to favor one or the other. So generally just don't do that. And then I don't have the logic in there for the fire, but I am checking for it. So I've got a bit of the code in there for that. And then I have this part here where I set the tiles, going back to this lookup table here for the tiles based on the position. I put those in there, and then I call this render Canon top, which is a sort of shortened version here. In video, I have render tiles. This renders the entire tile map. I only do this in the main loop because it takes a long time. It actually takes longer than a scan cycle to complete. We don't have enough time in between each interrupt to go through the full render tiles thing. So to avoid any stickiness on that, I go ahead and just these 8 tiles, I go ahead and re-render, and then that's pretty quick. So I get through that, and then we're done. I may even tighten this up a bit more so that I just do that first row, and then at the end, because you'll notice here, I'm always having this 2, 3. This is the top of the ball that's in there. I may do the second row. I may unroll that a little bit and just go through this process for the first one, the second one. But it's kind of hard to unroll. It's going to add quite a bit more code. I think I can afford to do that. I RAM-wise, I should have enough RAM to unroll that. But yeah, we'll see how that goes. And yeah, so that's pretty much where everything is at. So that's all I have for you today. I hope you enjoyed this little insight into how pop is coming along. And if you have any suggestions, please feel free to put them down in the comments. Of course, as you can see, I am far from finished on this. The looks are pretty much where I like them in terms of what you've seen so far, but I have a lot more that I can do if there's some ideas of things to put on the sides or any other little things you think might look nice, just let me know. And if you really are interested in finding out more, please subscribe to the channel and click that bell for notifications, and you'll know when the next episode comes out. You'll get my tutorial videos, my other edited videos, and along with these informal vlogs taking a look at the game. And of course, this game is free and open source, and it's going to be available in perpetuity on GitHub. The GitHub link is going to be in the description. But after all that, if you still just can't wait to see the next vlog or video, go ahead and join these fine folks you see on the screen now in my Patreon community, and you'll be able to see my videos as soon as they're ready, and without having to deal with any of these pesky ads. So not a bad deal. So come support my channel and support my ability to make games and create some great content here for you folks on YouTube. And that's all I got for you today. I'll talk to you again soon. Bye-bye.